Hello everyone, so welcome to today's class. Today we are going to learn about the left topic of CD. Okay, as we have completed with as we have completed with TOC completely. Okay, so let's see today's topic of CD. Okay, today's remaining topic of CD let's cover. And I want to tell you that I am taking the subjects revision where I have taken algorithm C and DSA. Algorithm C DSA covers up to 18 to 20 marks, 18 to 22 marks, okay, and TOC to CD covers 10 to 15 marks somewhere every year. So if you take the bigger of this, so 22 and 15, so this will be 37 marks, and plus additionally if your aptitude is strong, so it will cover up to mostly 52 marks. Okay, so that is why if these subjects, if you're planning for 45 plus marks in this paper, so if you just do this subject and maths aptitude, you will gain marks. And also there are some subjects like DBMS is very scoring, maths is very scoring, digital is very scoring, so easily you can get 50 plus marks. Okay, so from the weightage wise I am taking the revision. Okay everyone, so let's get started with this. Let's revise CD very perfectly, and if you have any doubt you can ask me. Okay, so in CD today we are going to cover CFL. So let's note some point about it. CFL is more powerful than DCFL. Okay, and we all know that there is a stack. Okay, it's a stack like this. The initial symbol is here Z0. Okay, and the stack is like infinite. Okay, and initial, and this is called as initial stack symbol. Initial stack symbol, this is called as initial stack symbol. Okay, and there are 7 tuples, so 7 tuples. It is Q0 F like this. This is some symbol tau and Z0. So here the initial is tau, and this is called as stack alphabet. Okay, this Z0 is initial stack symbol, and F is final state, okay, which can be empty. Alright everyone, now let's see the notation of DPDA and NPDA. So DPDA is okay, so I think we did this, right? Yeah, so today we should start with grammar because already this we have seen, right? So in yesterday's class only we have completed this. So today we should start from grammar, right? This we have already covered, so there is no point in repeating this again. Okay, so let's start with grammar, right everyone? So from grammar only it was left. Okay, so let's see the grammar one. So this is compiler design we are studying. In that, let's talk about now grammar. So in compiler design, we only use type 2, which is CFG, and type 3, which is regular grammar. Okay, so compiler is equals to program of grammar, and compiler is also membership program, membership algorithm, and every programming language is context sensitive grammar, which is also called as context sensitive language. Okay, and there are parse tree also and syntax tree also. So parse tree is denoted like this. Parse tree is denoted this way, like it's E. Here is E plus T F, and after that this is T, this is T F, this is F. So here is 2, here is 3, here is 4. Okay, so this is a procedural. Every int node is variable and whole derivation is presented. Okay, whereas if we talk about syntax tree, so it's like syntax tree. So this will be denoted like this, plus 4 multiplication 2 into 3. So this is completely non-procedural, and int node is operation, where here int node is variable, here int node is operation. Okay, and after that we have to check the priority or associative. So randomly derived till you have enough operation, and then you have to check which is done first. Okay, if the priority of two operators are same and both left and right associative, then it is this is ambiguous grammar. Okay, so if the priorities are same and both are left and right associative, so they are ambiguous grammar. All right, now let's talk about types of item in bottom-up parser. Types of item in bottom-up parser. So the first is, this is atom. First is reduced. Okay, and the next is unreduced. So let's learn about this. So this is x alpha dot. Okay, so dot and at the end, dot at the end, that means this is reduced. But if you have like this state where x deriving alpha dot t beta, then this t belongs to non-terminal. Okay, so here variable after dot. All right, and after that this is shift. So x alpha t beta. Okay, and here t belongs to terminals, and here the terminal. So either the dot can be after variable or it can be after terminal. Terminal after dot, then we have to perform shift operation. Okay, otherwise if it is after variable, then state will be changed. All right, now let's talk about syntax analysis parsing phase. Okay, so let's see this in detail. Syntax analysis or parsing. So in this phase, what happens is grammatical errors is checked, right? Anyone having any doubt till now? Okay, so let's see the definition first. Grammatical errors are checked. Grammatical errors are checked with the help of parsers. Okay, so with the help of parsers, so it is like syntax analyzer. Okay, it goes from lexical analyzer, okay, like this, right? Now, so for example, parsers are basically DPDAs. Parsers are basically DPDAs. Okay, now let's draw a parse tree. So this is a parser. So on the one side we have top down parser and the next is bottom up parser. So here we have top down parser, okay, and the next we have bottom up parser. Okay, and generally bottom up parser, from there questions are asked. So here in the top down, but that doesn't mean that you don't have to do top down. You also have to do top down as well. So here with backtracking, okay, and this one will be without backtracking. So with backtracking, the first one is recursive and the second is non-recursive. NR means non-recursive, just understand. Without backtracking, the first one is recursive descent parser, and without not backtracking, non-recursive descent parser. Okay, non-recursive descent parser. This is very important. We can say that LL1 or predictive parser. Like this. Now for bottom up, so the first one is LR0, okay, SLR1, after that LR1, after that CLR1 or LR1, like, and this is most powerful parser. Okay, so all of these parser are table driven. So we have to draw the table to solve this. Alright everyone, now let's see the next one. So parser is equals to what? DPDA plus parse table. Okay, now let's see one by one. Parsers generate parse tree for a given string by the given grammar. Now let's understand top down parser, which is LL1. Okay, top down parser which is LL1. So the very first is, it uses LMD, leftmost derivation, and is equivalent to DFS, which is depth first search in graph. Okay, so it is like this. So after that you should know the algorithm to construct parsing table. Okay, this thing you all should know. After that, the removal of common prefix, this also you should know, which is also called as left factor. So some of the topics which you should know in detail, which I am writing here. Okay, so construction of parsing table, this all you should know. Okay, and after that, left factoring also you all should know. So you can just see 1 to 2 questions on this and you all will be okay. So as this is the revision class for the theory, okay, so that is why I'm not taking any questions in this. So basically the questions are asked on question based, okay, not much theory is there. So that is why I have written the topic which you should just practice the questions of them. All right, now let's focus on first and follow. Okay, first and follow. First and follow. So what is first set? First set is nothing but extreme left terminal from which the string of that variable starts. Okay, and the first thing you should notice, it never contains variable, but may contain epsilon. May contain epsilon. Okay, may contain epsilon. So we can always find the first of any variable. Now this is the first set. Let's discuss follow set now. Follow set. So follow set is, it contains terminals and dollar symbol. Okay, so it can never contain variables and this epsilon. Okay, so the question is how to find follow set now. First you have to include dollar in follow of start variable, and if the production is of type, like let's say A deriving alpha, B, beta. So here alpha and beta strings of grammar symbol. So what you have to do in this, you have to do follow of B. Follow of B is what? First of beta. Follow of B if you have to find, so it is first of beta. If you have to find follow of B, so like this you have to do. Okay. Okay, so now let's see some important things. So this also numerical questions come from here, not numerical but just MCQ questions come. Highly chances are there that the questions can be asked from this topic. So please be clear about all these things. Okay, now let's note some important entry points into table of top down. Okay, so next topic is entry into table top down. Entry into table top down. The very first is number of rows is equals to number of rows is equals to number of unique variables in grammar. Second is number of columns is equals to terminals plus dollar symbol. Third is for a variable row, fill the column which is terminal if it's there in its first with the production require. Okay, with the first with the production required. All right, after that, fourth one is if epsilon is in first. Okay, so put v epsilon under dollar and its follow. In follow and under dollar you have to put. Okay, and if any cell has multiple items, then it is not possible to have LL1 parser. So this is also very important point. Fifth is if any cell has multiple items, then it is not possible to have LL1 parser. Okay, since that will be ambiguous. All right, so the point you should note, in top down we do derivation. Okay, and in bottom up we do reduction. All right, so after that, left recursion, left factoring should be absolutely clear to you all. Okay, and please see questions on this. After that, we will see the hierarchy of parsers for epsilon free grammar. Okay, I hope there is no doubt till now. Okay, so let's move ahead with this. So hierarchy of parser. So see, how is the table? The very first here okay, so I am drawing a table so you all can get that. So this is a table. Like this. Okay. C. So here it belongs to CLR 1 of LR1 or LR1 also we can say. Okay, here LA LR1 and here is like this. So here basically we have LR0, okay, here LL1, after that here SLR1, like this. Okay, so for epsilon producing grammar, every LL1 may not be LALR1, okay. And the note is you cannot construct any parser for ambiguous grammar. Okay, so let me write this point. Can't construct any parser for ambiguous grammar except, what is that? Except operator precedence parser. Except operator precedence parser. Okay, so operator precedence parser possible for some ambiguous grammar. Okay, and there are some unambiguous grammar for which there are no parser. There are no parsers. For example, I will give you one example on this. For example, see, S, this is the grammar. S is denoting SA, after that B, SB, after that AB. So what is the language here? The language of the grammar is WA plus B WR. So this is nothing but odd palindrome, right? And here this is unambiguous, but still no parser. Unambiguous but no parser. Okay, so I hope the line is justified that there are some ambiguous grammar for which there are no parser. Okay, now let's see the next point. Every regular grammar is not LL1, okay, as it may be ambiguous, or recursive or common prefix one. Okay, and parser exist only for the grammar if its language is DCFL. Okay, if its language is DCFL. So there are some grammar whose language is DCFL, but no parser is possible for it. So there are some grammar if its language is DCFL, okay. There are some grammar whose language is DCFL, but no parser is possible for it. No parser is possible for it. So you have to check operator precedence parser. Okay. So do check for it, okay, everyone. I hope the top-down parser is absolutely clear and there are no points left for this. Some of the interesting questions are there which are asked for 1 to 2 marks, okay. So that you need to practice by yourself. And please pick previous year. Focus on previous year as much as you can, okay. Because previous year will tell you what kind of questions will get asked. And if you will see the online questions, so they will misguide you and you will feel and they are generally tough, so they may misguide you, okay. So please be focused on only PYQ. Now let's discuss bottom up parser. Bottom up parser. Bottom up parser means it uses rightmost derivation in reverse and has no problem with first is left recursion, second is common prefix, okay. So SLR1, LR0, okay. So these are LR0 items, CLR1, okay, LR1, these are all LR1 items. So LR1 is equals to LR0 plus look ahead plus 1 look ahead. Okay, got the difference? Now let's note some crucial points. No parser possible. So you know, no parser is possible if the grammar is ambiguous grammar, and there are some unambiguous grammar for which there are no parser. I have noted this, and the language for the grammar must be DCFL. Okay. Now you should know the basic algorithm of construction of LR0 table, LLR1 table. Okay. So for that you should know the entries, which is shift entry, state entry, reduce entry. Okay. And all of this. Now let's discuss about the conflicts. Let's discuss conflicts in detail. So the first is LR0 parser. In LR0 parser, the conflict is SR, shift reduce conflict. Okay. It is SR, which is shift reduce conflict. Shift reduce conflict, and see how it is like S is X. Okay, so shift, I am talking about shift conflict. So shift conflict is like X is deriving alpha dot T beta. Okay, and the reduce, and here in the same state it has, this is the shift conflict. Okay, and here the reduce is there, like Y is deriving some let's say alpha dot, like this. So then this is SR conflict. Okay, this is SR conflict. Now let's talk about so this is same. Now here for LR0 let's discuss RR conflict. Okay, for this let's discuss RR which is reduce conflict. So reduce conflict is very simple. Here this is the state where x is alpha dot, y is beta dot. So this is R and this is R, reduce. So this conflict is called as reduce. And this we have studied in LR0 parser. Now let's see for the SLR1 parser. SLR1 parser. So let's first see SR conflict. So SR conflict is like, this is a state, x derives y dot t b, and y is again some, let's say this symbol dot. Okay, so this is S, this is R, but here we have to check that whether this t belongs to follow of y or not. So this is AND. First SR should be there and this t should belongs to the follow of y or not. And if this is the case, then this is SR conflict. And now the RR conflict is like, this is RR conflict, x deriving like this, y deriving like this, and follow of x intersection follow of y not belongs to phi. Then this is RR conflict. Okay. Now let's discuss LALR1 and CLR1 conflict. So it will be also same, right? But now the look ahead will be there. So see this, LALR1 and CLR1. So SR, so this will be like x deriving alpha t beta L1 and y deriving some symbol 2. So this is the case, and if this t belongs to L2, okay, then here will be SR conflict. Okay, here RR conflict means what? This is the state, x deriving like this L1 and y deriving beta L2, and L1 intersection L2 is not phi. Then this is RR conflict. Okay, RR conflict. Now let's talk about what is inadequate state. Any doubt till now? So let's discuss inadequate state now. Inadequate state. So it is a state having any conflict is called as conflicting state or inadequate state. Okay. So the only difference between SLR1 and LRR1 is that states with the similar atoms but look aheads are merged together to reduce space. Okay, so one formula, adequate state definition is clear. Any conflicting state is called as that. So one thing you should note, number of states in LR0 is equals to number of states in SLR1 is equals to number of states in LALR1, okay, smaller than equals to number of states in CLR1. Okay, now let's note some important points. First is, if CLR1 does not have any conflict, then conflict may or may not arise after merging in LALR1, Second is, if LALR1 has SR conflicts, then we can conclude that CLR1 also has SR conflicts. Okay. Third is, LALR1 has SR conflicts if and only if CLR1 also has SR conflict. Okay. So we can construct parser for every unambiguous regular grammar. Okay. I hope that this is absolutely clear. Now let's see lexical analysis phase. Okay. Lexical analysis phase. So lexical analysis means, first is character stream is there, lexical analysis, and it generates token. So this is the flow. Char stream is there, then lexical analyzer. After that, token stream it's generate. Okay, so it can be also called as token generator, scanner, linear phase, token recognizer. These are all the names. You all can note that. And what is the definition? We have to scan the whole program character by character, produce the corresponding token to it. Okay, and also produces reports to lexical errors if any. If there is any lexical error, we will report it to you. So what is the functions of lexical analyzer? Let's write functions. So the very first function is scans all the char of the program. Second is token recognizer. Third is ignores the comment and spaces. Fourth is maximal, okay, munch rule is applied, which is longest prefix match. Okay, then the lexical analyzer uses regular expression, right? So what is lexeme? Smallest unit of program or logic. What is token? Internal representation of lexeme. And what are the types of token? Identifier, keywords, operator, literal, special symbol. And what is token? Separation, spaces, punctuations, right? And all one identifier will entry into symbol table. Okay, and lexical analyzers gives entries into symbol table. So it is like a regular expression. After that, DFA, then lexical analyzer. Lexical analyzer. All right, everyone. And also you can practice the questions of finding tokens. That is also very, very important. That can get asked in the paper. So you should be aware about how to find the tokens. Okay, how to find the tokens, that you should know. After that, let's see syntax directed translation. Syntax directed translation. So syntax directed translation is CFG plus translation and syntax plus translation. So this is nothing but SDT. Okay, and what is SDT? CFG plus translation. And what is translation? That means meaning or semantic. Okay, and what are the applications? Applications of SDT is, the very first is use to perform semantic analysis. Second is produce parse tree. Third is produce intermediate representation. All right. Fourth is evaluate an expression. Okay. Fifth is convert infix to prefix or postfix. Okay, like this. The attributes can be inherent attribute and synthesized attribute. So we will discuss that too. So if I just draw the tree of A, B, just let me know. S, A here will be, A here will be, here will be A, and here will be B, like this. So S is what? The parent of A and B. A is the child to S. A is the left sibling to A and B. These are the terms you all know, right? So note this, everyone. Okay, now let's discuss types of attribute. Only 2 categories of attribute are there. Let's discuss those. Attributes the very first is inherited attribute, which is RHS. Okay, which is RHS. So it's like S A B. Here A dot X is equals to function of B dot X and X dot X, like this. Okay, so the computation at any node which is non-terminal depends on parent or siblings. Okay, so in this example, X is what? Is inherited attribute. Inherited attribute. Now let's see the next one. Synthesized attribute, which is LHS. Okay, Here is, see, a s deriving ab. After that, s of x equals to function of a of x, b of x, like this. And here x is synthesized attribute. So here the computation at any node non-terminal depends on the child. Okay, now you should also do the practice of identifying types of attribute. That you should do, okay? After that, the next is syntax definition transaction. Here we have L attribute grammar, L attributed grammar, and S attributed grammar. So we will see that as well. Okay, so let's get started with L attributed grammar and S attributed grammar. Very first is attribute is synthesized or restricted inherited. Okay, here is attribute is synthesized only. Second, here is parent, and here is left sibling only. Second is translation can be appended anywhere in RHS of production. Okay, and here is the translation is placed only at the end of production. Only at the end of production. So evaluation is always in order, which is topological, okay? Here the point you should notice, every S attributed grammar is also L attributed grammar. And L attributed evaluation uses in order annotation parse tree, and S attributed uses reverse of rightmost derivation is used in S derive. Okay, which is first we have to find the RMD order, and after that we have to consider its reverse. I hope there is no doubt till now. Let's see now intermediate representation. Intermediate representation. So representation the very first is linear form, and the next is non-linear form. So in the linear form what comes? Prefix code, okay, 3 address code. Third is static single assignment, that it comes. The first is syntax tree. Second is directed acyclic graph, which is also called as very famous DAG. Third is control flow graph. Control flow graph. Okay. Now I will just take one example, and in that everything will be clear. So the expression is y plus z into y plus z. So the postfix, how the postfix will be represented? Postfix will be represented as yz plus multiply, like this. Okay. And 3AC, 3 address will be represented like this. T1 equals to y plus z. T2 equals to T1 into T1, like this. Now SSA, okay, which is static single assignment, it will be like T1 is equals to y plus z and T2 is equals to T1 into T1. Okay. And here T1 and T2 cannot be reassigned. Syntax tree, it will be multiply plus yz and here plus yz. Okay. And DAG is like multiply plus yz. Okay. So reuse the already existing common sub expression. Okay, and in the 3 address code means what? Code in which at most 3 addresses are there. So address name variable constant, like that. So you should know this because the question can get asked from here as well. So you should know static single assignment, the problems on that. You should also know control flow graphs, how they are drawn, right? Okay. So the very last topic is code optimization. And soon we will look into it. Any doubt till now? So code optimization. Code optimization we will revise in 10 minutes. Okay. In the remaining 10 minutes, we will revise code optimization. And can you comment which is the next subject you want me to take revision of? So today, can you all comment that which is the next subject I should take revision on? So the revision part, C is over, programming is over, algo is over, data structure is over, TOC is over, today CD is going to get over. Then which is the next subject you want me to take revision? So in tomorrow's class basically. Can you all just answer in the chat box that which is the next subject I should take revision? Programming is completely over. TOC and CD is also over. Now the next subject which I should take revision. And see, most weighted subject I am taking first because it will benefit you only. Okay. Now the last part left is code optimization only of CD, and completely compiler design is over. I have only left the numerical question which you need to solve. Rest all the theory is covered. Any doubt till now, everyone? Please answer in the live chat. Okay, I think you all can tell me which is the next subject should I take in the revision for tomorrow. Okay, so let's discuss code optimization. Code optimization. Last topic of compiler design. So what code optimizations do? It saves space, or we can say that it saves time as well. So the basic objective of code optimization that it should save our space, and it should save our time as well. Okay, so optimization is divided first into high level code optimization, okay, then intermediate code optimization, and third is assembly code optimization, which is machine dependent, and these are all machine independent. All right, so flow analysis we have control flow graph, and we have data flow graph. Okay, and optimization has local, which is called as intra procedural basic block, and the global one is inter procedural whole graph, whole program. Okay, and optimization methods are, the first is constant folding, second is copy propagation, third is strength reduction, fourth is dead code elimination, fifth is common sub expression elimination, and sixth is loop optimization. So here comes code motion. Okay, after that induction variable elimination, then loop merging, and loop unrolling. All this you should know. Okay, so the first is constant folding, you should know how to do it. Second is copy propagation, so every single thing you should know. So that is why hence it is a code that never execute during execution, and we all can delete such code in the delete code optimization. So all these written methods you should be aware of, okay, because directly question can come from this. So loop unrolling also you should know that how many statements will be there. So easily a mark question, 1 mark question can get asked from these topics. All right, everyone. Any doubt till now? See, for example, if you want to see the last loop unrolling problem, so let's say for is there, I equals to 0, I smaller than 3, I plus plus, if it's there, and we have to print CD. So can you all tell me that what is the loop unrolling for this one? How much that will be? What will be the answer for this one? Anyone in the chat box? Anyone can answer. What is the loop unrolling? How many statements will be there in this? So this is the last problem of the class, and here our compiler design is over. Any doubts if you have regarding preparation, regarding any subject, can ask me. So printf will be off. Printf will run for how many times? 3 times. 3 statements. So it is 3 into 3 plus 2 is 11 statements. It will go. Alright. Any doubt till now? Any questions that how this came? How the answer came? So that was all for today's class. Okay, everyone. TOC and CD is completed. After that, the most weighted subject is, and that is easy also, is DBMS. It comes for 8 to 10 marks, and scoring on this subject is really very easy. Okay, so I'm planning to take that next. Okay, it's nothing but DBMS. That is what I'm going to plan next for you all. So if you know aptitude well, if you know whole programming well, if you know TOC, CD well, okay, so, and if you know DBMS well, 10 marks. So add up this, everyone. So what is the BO of this marks? 15 plus 22 plus 18 plus 10, 65. So let's say this 8 to 10, so 55. 55 plus marks, easily you can score on this. So total programming is C, data structure, algorithm, everything, and TOC, CD and DBMS. Okay, and 55 plus, if you again add digital, which comes from for 3 to 4 marks only, but still, so you can touch for the 60 as well. Okay, everyone, so please practice these subjects very properly and do revise the concepts very frequently. And this short revision will help you a lot in revising things. Okay, everyone. So now only very few days are left. 10 days are only left for the exam. 10 to 11 days. Okay, so all the best, everyone. If you have any doubt, you just can ask in the comment. I will surely reply. So thank you so much for today's session.